Hello. Yeah, may I know how many of you have taken this honors course? Because I had no idea that how many of you have taken this course.
I'm 18.
18. Are you
Yes,
sure?
yes, ma'am.
Okay. Thank you. I am starting now. Now this is visible to all of you.
Yes, yes, ma'am.
Okay, now first of all, I would like to introduce you to the entire course of computer networks because this course has two parts. Part one will be covered by Professor Resi, and the second part, which is computer networks, will be covered by me. And this is the course contents of part two. So first one will be the introduction to computer networks, and then we are going to discuss about the transmission media, and then error detection, and how we are going to, by which method we can able to detect the errors. And then we are going to study encoding schemes. That means when because in computer communications the digital the signal will be digital, either in one zero or one form, but zero or one we can't able to send through the transmission medium. We have to convert that zero and one with the help of some electrical signals, and based on those we have some encoding schemes, so we are going to learn that. Then we have to study local area networks, which is LAN, and the protocols that has been used in LAN, and how the networks connected in LAN can be able to talk to each other. And then we have a wireless LAN, and this local area, this is an wired LAN, and then we have to study wireless LAN. Of course, the protocol used in wired LAN and wireless LAN will be different. Then we have to study circuit switching and packet switching. In circuit switching, it is analogous to telephone network, by which we are two people can talk to each other. And packet switching, here this is also, and circuit switching and packet switching falls under wide area network now, and this is local area network, and the this network has been decided based on the area covered by the network. Now, local area network, it's the area covered by this network will be small, and wide area network, it will be bigger. Size of the network will be bigger than that of local area networks. This and circuit switching, packet switching falls under wide area network. And in wide area networks, so the protocols will again be different from local and wireless local area networks. Then we are going to study the routing. How could we control the, just like how could we control the error when the error occurs in data transmission, we can, how could we detect those errors and then correction by error detection and correction. Similarly, when we are going to send the data through the network, sometimes congestion has occurred in a network. So when the network is congested, how could we able to transmit the data? That will falls under traffic control, flow and congestion. And flow control is different, congestion control. Flow control, by flow control we mean that uh, when we have to send the data from sender to receiver. Now, if the sender is running at a faster speed than that of the receiver, so if then it will send the data at a much faster rate, sender will send the data. But since the receiver is slow in speed, so it couldn't accommodate that data. So by flow control, we can able to maintain both the transmitter and the receiver at the same speed. This is what we mean by flow control. Then we have an internetworking. That means how could we connect the computers in a local area network and in a wide area network. So this whole network is known as internet. So how could we transmit the data in those cases? That will be falls under internetworking. And to transmit the data, now some since the local area network and wide area network, which is circuit switch and packet switch network, I have told you both the local area network, wireless area network, and wide area network, they are working with different protocols. But so since they are working with different protocols, so one network, if we want to send the data from one local area network to wide area network, that means packet switch network, since their protocols are different, so the information or the data sent by local area network to the wide area network computers, the computers which are connected in wide area network, they couldn't able to understand that. Now, so we can do that with the help of routers. One of the function of the routers, it will act as a mediator between local area network and wide area network. Just like if English people, English talking people is going to have a conversation with people what talking in French language, the French language French one will not be able to understand the English language, and English language talking people cannot able to understand the um, French language. So there will be a mediator between them who understood both the French and English language. So the router will function as that. That is why routers is also used to interconnect different networks. Then how could we transport the data, how could we send the data through the internet? That will falls under internet protocol and transport protocols. And of course for the last one will be the security. When we are going to send the information through the network, our main aim, how could we secure our data? So there are several techniques how could we secure our data during transmission through the channel. That falls under network security. So this is all about the syllabus of the principles of communication engineering and computer networks part 2. And some ebooks I have given here, and you have to download these ebooks from the net. And because these ebooks are available in net, besides you can also uh, use some books because now our library is open. So if you come to the library, then you will also get other books in which has been kept in our library. But I hope that these 3 ebooks will be sufficient for you to understood these course. Besides that, I am going to send you notes. And now I know that you are not going to read my, because last year when I took the class in computer network, that time it is common to all. And I have heard that nobody has studied my notes. And when I send the assignment, they simply copied, they form a group and they copied from each other to answer my assignment. So nowadays, since no offline examination is going on, everything is online, so you have a facility of doing this. But this time it couldn't be happened because I will send different set of questions, and the time limit will be, say, for if the class test will be held on 15 marks, you will get only 1 hour to submit or to upload your, after finishing writing, you have to submit it within an hour. And if it is an 100-mark semester, then you have 3 hours to submit your answer scripts. But this time this is not going to happen. And I will set since you have taken only 18 students are here as per your information, so I will set different questions. And these are the, after we finish the course outcome, there will be, and this the whole uh, principles of communication engineering and computer network course have 5 outcomes. And these are the course outcomes. One, and this is 2, and out of these 5 outcomes, uh, we have CO3, CO1, CO2, CO3, and CO5 will be falls under computer networks, and CO4 will be solely for part 1. So these are the course contents, these are the course outcomes, and I have given the you the name of the ebooks. First one will be the Computer Networks by Tannenbaum, and second one, Data and Computer Communication by William Stallings, and third one will be the Principles of Digital Communication System and Computer Networks by K.V. Prasad. So you remember the name of the authors of these three books, or you may write it so that you can able to download it from the net, because I am not going to send uh, this file to you. Okay, if you want to write the name of the ebooks that you have to download from the net, you can write it down. Okay. Hello. Okay. When you finish writing, then tell me. I will start my first topic today. Okay, you have finished it. Okay, thank you. So we are going to start with Introduction to Computer Networks. And this is the first topic of your Computer Network course, Part 2. Now, before going to start going detail into the computer networks, here we have to first have some idea about a communication system or a model. Now, by communication, what we mean to send information from sending side to the receiving end side. To do that, we have to use this model. This is a communication model or signal transmission model. And from here figure, what we have seen, first one will be the information source. So this information source, it will generate an information signal or message signal that has been transmitted through the, and this small block is we have taken it to be a channel or a medium, through the medium, so that we can able to send it from the, say, this information source and transmitter, we take it to be a sender, and receiver and destination, it will be the receiving end side. So uh, to transmit this information or information signal, or this information signal can also be known as a message signal, from the sending end side to the receiving end side. Now, this information source may be a transducer, which will convert non-electrical quantity into an electrical one. So just like, say, microphone, which will convert sound into an electrical signal. Now, generated information signal generated by the information source, based on the frequency content of the signal, we can divide this signal into two types. One is known as baseband signal, and another is known as broadband signal or a carrier signal. And based on that, the first one, which will transmit baseband signal, that is known as baseband signal transmission system. And when we are going to transmit broadband signal, that signal transmission system is known as broadband signal transmission system or carrier transmission. Now, what is the difference between baseband signal and broadband signal? Now, in baseband signal, we are going to transmit the raw signal produced by the information source. That signal is known as baseband signal. And what is broadband signal? Now when this signal is modulated, when the baseband signal, because actual signal will be the baseband, but instead of transmitting that signal through the transmission medium, when we modulate it with the help of a carrier, that is known as transmission. Now, to find out the analogy between baseband signal transmission and broadband signal transmission, we can say, if we want to throw a piece of paper, which is baseband transmission, it will not go very far. But if we wrap it with a stone, which is equivalent to carrier transmission, because we are going to send the same paper by wrapping it with a stone, then we can able to send it far distance. So the wrapping of paper with a stone is known as carrier transmission or broadband signal transmission. Broadband means the signal spectrum will be broader, and is in baseband the frequency spectrum of the signal will be narrower, because suppose we want to send a voice signal, so it will occupy a specified band. But if we sending the same voice signal by modulating it with a carrier, and the carrier having a carrier is nothing but a sinusoid having higher frequency than that of the frequency of the baseband signal, and then we can able to shift the frequency spectrum of a signal so that it will be broadened. That is why we call it to be a broadband signal. Now, again, this baseband signal transmission and broadband signal transmission are are of both analog and digital. And in analog baseband transmission will be where we are going to send the signal produced by the information source uh, itself. That falls that can be divided into two categories. One is analog voltage transmission and another is analog and the baseband signal transmission. So this will be the analog voltage transmission and analog current transmission. This will be the analog transmission of baseband signal. Similarly, the baseband signal transmission is in digital form also. In digital form, it is known as pulse code modulation or PCM. So PCM is an example of sending baseband signal in digital form. Similarly, in broadband or carrier communication, and we have analog and digital part. And in analog part, we have amplitude modulation, frequency modulation, and phase modulation. Whereas in digital form, we call it to be a amplitude shift keying, phase shift keying, and frequency shift keying. Now, why digital carrier communication is known as a keying process? Because we know digital data has two levels only, either 0 or 1. So we equivalent to a keying process. That means when there is a key or when the key is closed, we have one value of the signal, and when the key is open, we have other value of the signal. That is why digital carrier communication or digital broadband signal transmission is termed as amplitude shift keying, frequency shift keying, and phase shift keying. Now, in amplitude modulation or in amplitude shift keying, the amplitude of the carrier is being modulated with the baseband signal, because our main aim is to send the baseband signal, but in broadband communication we will send the signal after modulating it with a high frequency carrier. And in amplitude modulation we are simply change the amplitude of the carrier signal to send the information. So the information lies on the amplitude of the carrier signal. Similarly, in frequency shift, in frequency modulation, or in FSK, which is equivalent to FSK in case of digital carrier communication, the information lies on the frequency of the carrier signal, and in phase modulation the information lies on the phase of the carrier. And then so this is all about how could we distinguish the baseband signal transmission system, baseband and broadband. And now we use this message signal is then fed to, from the diagram what we have seen, it is being fed to the transmitter, and the transmitter modifies the signal for efficient transmission. Now this transmitter may be a modulator, may be an encoder. So now why we call this to be an transmitter is used to transmit the information for efficient transmission. This can be stated in this way that suppose we want to transmit several informations through a same communication channels. That means, say we are going to suppose the 5 human voices at the same time through a same channel. Now we know the voice frequency will cover voice frequency of 5 different signals will occupy the more or less occupy the same band. So when we are going to send it through a same communication channel, in that case at the receiving end side, instead of getting 5 separate voice signals, we will get a composite signal, which is why this signal is known as composite, because voice frequency more or less occupy the same frequency band. So we couldn't able to distinguish one signal from the other. So we are getting a mixed signal at the receiving end side. Now, instead of sending 5 voice signals through a same communication channel, if we want separate channel for each of the 5 signals, then we can distinguish each signal from other at the receiving end side. But if we have to use 5 different channels, in that case, the cost of transmission will increase. So but if we can able to send more information through a same channel at the same instant of time, then we can able to decrease the cost of signal transmission. And the transmitter, one of the function of the transmitter, it will do help us to do modulation. So it is so the transmitter is known as also a modulator. And then after modulating the signal, now if we modulate the information signal with a high frequency carrier signal, and each signal for each separate voice signals. If we choose carrier signals having different frequency, so we can able to shift the frequency spectrum of the signal in such a way that the frequency spectrum of the different signal will occupy different frequency band. Now, when the different signal will occupy a different frequency band, then at the receiver, we couldn't able to, it is not difficult for us to identify each signal from the other. That is why we call the transmitter, it is used for efficient transmission of the signal, which is an information signal or a message signal or a baseband signal. In broadband transmission, we are sending the same information signal, which we call it to be a baseband signal, but in a different way to take the advantage of a communication system. So the function of transmitter is clear to you. Hello? Hello. Now, when the this is the this signal is known as transmitted signal, and this is a channel. Now, when the transmitted signal is sent through a channel, now here the a noise will be incorporated here, and the received signal, it is mixed up with noise, and the function of the receiver is to uh, modify the received signal in such a way that it will be interpretable as a message signal to the destination device. So the function of a receiver is inverse to that of a transmitter. So if the transmitter modulates the signal, the function of the receiver will demodulates the signal. And if it is an encoder, one example of an encoder, if we want to convert analog information into a digital form, we have to use digital to analog converter. So if the transmitter is an encoder, which is nothing but analog to digital converter, receiver will be digital to analog converter or a DAC. In that case, the receiver will be decoder. And the destination, it will receive the information from the receiver. Now, when the signal is passed through a channel, here noise will included in the signal, and this noise signal is nothing but an unwanted signal, and this noise signal will, we cannot eliminate this, but we can able to minimize it. Now, due to the presence of unwanted signal due to when the signal is being transmitted through a channel, due to that, in analog transmission, the signal strength will be degraded, and in case of digital transmission, bit error will occur. uh, Now, what we mean by bit error, that means say we want to transmit 1010, but at the receiving end side we are getting 0010. So the first one will be converted into a zero. So instead of getting one from the transmitter, when the transmitter is transmitting one, digital one, if we are getting digital zero at the receiver, so an error, this is known as bit error, And this type of error occurs in case of a digital transmission, which we call to be a beat error. And in analog transmission, the signal strength, that means the amplitude of the signal, will decrease, or the signal strength will decrease in case of a analog transmission. Now let's go to that. Now before here is an example of an amplitude shift keying. So this is our message signal or an information signal. And this will be our carrier signal, and it has a high frequency sinusoid. Now in ASK we have two outputs, because the message signal has two forms. This is high level and this is low level. This represents 1 and this represents 0, suppose. So here, for when 1 is being transmitted, we have this signal, and when we have 0 is being transmitted, we have 0 here. So the this is a digital carrier signal, and it has two values for two different values of the message signal. When the signal is present, we have 1 amplitude, and when there is no signal, we have 0 amplitude of the signal. So here what we have seen, the amplitude of the carrier is being modulated with a message signal. And since the message signal has two values, ASK output has two values. Similarly, for frequency shift keying, this is a data and this is a carrier. Now here the frequency of the carrier is being modulated with the message signal, or which is the data signal or a message signal. So when it is 1, when the digital data is 1, we have one frequency, and when it is digital 0, we have another frequency. So the frequency of the carrier is being modulated with the message signal. Since the message signal has two values only, it is having two values. Here we have one frequency values for 1, and for 0 we have another frequency values. Clear? Hello?
Yes, ma'am.
Now, communication channel, it is a medium through which we are going to send a signal. And this communication channel, we have a guided or unguided medium. Guided medium, we have we can transmit the information through twisted pair cable, through coaxial cable, through an optical fiber. This falls under guided transmission medium. And unguided means when we are going to transmit the data through an air, so that is known as unguided medium. And unguided medium, nowadays we can use satellite, radio link, or radio link. These are the unguided transmission medium. Now this is a computer communication through an RS-232C link. It is a this link is made up of a copper wire, and in computer communication, this is an example of computer communication. We are sending information from one computer through to other through RS-232 link, and this RS-232 link will act as a guided communication medium. Now, when we send through a telephone network, it will be the unguided. And here the digital, here we can able to send a digital signal, which is the PCM data or a message signal I have just shown to you. And when we send it to over telephone network, here we have to use modems. These modems at the sending end side will act as a modulator, and this modem at the receiving end side will act as a demodulator. And here we are using signal, either digital carrier signal, which is of the form ASK, PSK or FSK. But here we can able to send the message signal, which we call PCM signal, or this kind of signal. So this is an example of a baseband signal transmission between two computers, and we call this to be a baseband signal transmission because the information produced by the sending end side computer can be sent directly to the receiving end side computer without any modulation. Only we need a channel to transmit the signal. But here we have to use modulator modems at the both sides, at the sending end side and the receiving end side. So this is an example of a digital carrier communication. Now, transmission impairments, which has been occurred when the signal is being transmitted through the medium. And I have told you, for analog signal, these impairments degrade the signal quality. For digital, bit error may introduce, and as a whole it will degrade the system performance, both analog and digital system. Due to that, the receiver cannot understand the sender, the receiver cannot function as it should be, and reduce the efficiency of the communication system. So here, say we want to transmit this signal, and since the noise is incorporated in the signal, so at the receiving end side, so when the receiver receives this signal, so this is not an actual signal which is being transmitted by the sending end side. And these impairments can be of two types, attenuation and noise. Now, attenuation means the degrade in the signal quality or strength of the signal as the signal propagates through the transmission medium. Its amplitude is being reduced, or the amplitude is attenuated. Loss of signal strength with time, and attenuation in guided media is loss of signal strength with distance. So if at the beginning the signal of this strength, as it proceeds through the channel or a medium, the signal strength will be degraded. So to take this advantage, we can able to amplify the signal, and this amplifier we will kept at a distance apart in a transmission medium. So if amplifier, we amplify the signal. Here see that this is the original signal, and here it is being, when it comes here, it is attenuated. So if we are using amplifier, the signal is being amplified. But there is we can use amplifier or a repeater. And the difference between amplifier and repeater is that amplifier only amplifies the signal, but the repeater, I will come that later on. Here I didn't take the example of a repeater, how it not only amplify the signal, but it will reshape the signal also. So the repeater performs two functions. it will amplify the signal, as well as it will reshape or regenerate the original signal. And the another difficulties of using amplifier, that it will not only amplify the signal which is being attenuated, it also amplify the noise also. So the signal to noise ratio will be high, but our main aim in communication system to keep signal to noise ratio as low as possible. And what we mean by this signal to noise ratio, this will be the ratio of signal power to the noise power at the receiving end side of the transmission system or a communication model. And this signal to noise ratio is expressed in decibel or in dB. And the second type of noise, which is an unwanted signal, and these noise are of different types. We have a thermal noise, we have a short noise, we have an intermodulation noise, crosstalk, and impulse noise. And out of this thermal noise, we already know that this will be the thermal agitation of electrons in a conductors. And short noise is generally occur in active electronic components that has been used to transmit the signal through a channel. Now, if we first consider the thermal noise, so uh, the noise voltage is given as V square will be equals to 4k TBR, where K is the Boltzmann constant, T is the temperature in Kelvin, B is the bandwidth of the noise measured in hertz, and R is the resistance. Similarly, the short noise, it is found in active electrical components, and this is due to random fluctuations of emission of electrons. And this electrons means the it constitutes a current which we known as a noise current or a short noise current. And for if we take, before that, the thermal noise for bandwidth B hertz is given by N equals to kBT watt. Besides that, we have a white noise also before coming to the short noise. And white noise, what we if we plot the frequency spectrum of this noise, we have seen that this noise have a value, and this value has been over the entire frequency spectrum of the signal. So it is very difficult to eliminate white noise, but we can able to minimize it. Now, short noise, random fluctuation of emission of electrons, this constitutes current. And for diode, this expression is given as IN square equals to 2QI plus IS into B. Here Q is the electronic charge, and I is the forward current, and I is the saturation current in ampere, and B is the noise signal of frequency of the noise, bandwidth of the noise, in hertz. Now come to the intermodulation noise. Now when we are going to transmit two different frequency signal through a same communication channel, now this intermodulation noise has occurred because when the two signal passes through the same channel, we have a signal which constitute sum of these two frequency signal and the difference of these two frequency signals. So these are the because we are going to send the signals having frequency f1 and f2, but when we passing this when these signals pass through the transmission mediums, what happens, we have got another signal having a frequency component, which is the sum of these two components. If the signal frequencies are f1 and f2, so we have another signal having a frequency f1 plus f2, and also other signal which have frequency f2 minus f1 if we take f2 to be higher than f1. So this noise is known as intermodulation noise. So here we have a frequency f1 and f2, uh, and instead of getting f1 and f2 through the transmission medium, we have both a signal having f1 plus f2 and f1 minus f2. Now then we have a crosstalk. Now this is very common in telephone network, because when we are going to speak with people, uh, then we may heard the uh, talk of other people, and this is known as crosstalk, and this is due to the poor coupling of the two channels or the two transmission medium. And these coupling are resistance coupling, inductance coupling, and capacitive coupling between the two conductors carrying the signal. And this is the crosstalk, and this coupling depends on the geometric configuration of the conductors as well as the proximity of the transmission line. So if we keep the transmission line apart, then we can able to minimize this crosstalk. Now impulse noise, this is a high frequency noise or having high amplitude of a very short duration. Now let's see how it will affect the signal. Here I have taken one example of it. Say the data which has been transmitted is this 0101. So for 0 it will be 0, and for 1 the signal will be like this. So this is the digital signal, or we call it to be a PCM signal, and this is the impulse noise. Here we have a very high amplitude signal having a very short duration, here also and here also, and due to when it is superposed on this signal, we will get this type of signal at the receiving end side. So data received, what we are getting at the receiving end side, this uh, but instead of getting this signal at the receiving sorry, we are getting this signal at the receiving end side, but we have to get these data. So here one instead of getting 0, we will get 1 at this particular instant, and here also instead of getting 1, we will get 0. So beat error will occur due to the impulse noise. So this is the effect of impulse noise on a signal transmission system. So this is how the noise could affect the signal transmission through a channel, and by proper designing we can able to minimize it, but we couldn't able to nullify it. So the main aim of a signal transmission system to keep signal to noise ratio as low as possible at the receiving end side. We couldn't make it 0. Now, when we are going to transmit signal from the sending end side to the receiving end side, we have to do some work, and that is falls under communication task. Now, first one will be the transmission system utilization. Now, we can utilize the transmission system more economically, so that we can able to reduce the cost of transmission if we can able to send more than one information through a same transmission system. And how could we send the transmission system more than one signal through a same system, same communication channel or a system? That if we can able to do multiplexing. Now, multiplexing means one into many, and demultiplexing at the receiving end side, again uh, one into many signals. Sorry, multiplexing many into one and demultiplexing one into many. So how could we do that? We have to, there are two types of multiplexing system in analog and digital also. We have a multiplexing, and that is known as multiple access. In analog, this multiplexing is known as time division multiplexing, frequency division multiplexing, code division multiplexing, and in digital it is known as CDMA, FDMA. That means code division multiple access, frequency division multiple access system. So this is what we mean by, so one of the communication task is that, and we can take the advantage of a communication system if we can able to transmit more than one signal simultaneously at the same instant of time through a single channel. Then we can utilize the transmission system fully. Now, next, we have to, now what we have seen, to transmit the signal from sending end side to the receiving end side, we need some devices, and that is known as interfacing or interfacing devices we need. At the sending end side, we need a modulator, and at the receiving end side, we need a demodulator. This is nothing but an interfacing device, so that we can send the information efficiently through the channel with the help of interfacing device. And then the next one will be the signal generation, and we have to generate the signal in such a way. So signal generation is one of the tasks of communication, because we are going to send the information, and the information should be such that their strength should be, signal will be of strength such that it will not be degraded uh, while it passes through the channel, and at the same time it could be interpretable as a data at the receiving end side. And synchronization means we have to synchronize both the transmitter and the receiver, and this means synchronization. Now, exchange management, what we mean by this, this is also another communication task. Now, this suppose when two people talk to each other over the telephone network. Now, what the people at the sending end side will do, if he has a telephone receiver, he has to lift his telephone receiver, and he dial the number. Now, when he dial the number, it will generate a signal, and then that signal is propagated through the receiver, and the signal reaches to the receiving end side. Now, and this will, when the signal reaches to the receiving end side through the telephone network, what happens? There will be a ringing of the telephone at the receiving end side, and the signal transmission will not be completed unless and until the person at the receiving end side will lift its receiver. Now, when the person at the receiving end side will lift its receiver, then only the signal transmission has been completed and the two people can talk to each other. So this is known as exchange management. Now, error detection, I have already told you then why the error will occur. So the communication system should be such that it can able to, our task is that we can able to find out the error and we can able to correct the error. Now, flow control, that I have also told you. It means that when the we have in communication, we have a sender and a receiver. Sender at the, if the sender at the receiving end side will send the data at much faster rate than that of the receiver, that means the receiver is running slower than that of the sender, then the information that has been sent by the sender to the receiver will not accept that data at a at a faster rate because it is running slower. So we need a flow control mechanism so that both sender and the receiver, or the receiver can able to receive the data sent by the sender at a rate faster than that of the receiver, and this is known as flow control. Now, addressing and routing. Now, addressing means when we are going to send a letter to somebody, we have to put an address of the receiver. Otherwise, if we didn't mention the address of the receiver, the information will go to anywhere. And the routing, it determines the route through which the data has been transmitted. So this is falls under addressing and routing. And the recovery, if the fault is occur in a transmission system, then how could we again send the information? That is falls under recovery. And message formatting, we have several kinds of data, though they are digital. Some of the datas are in ASCII format and some of the datas are in EBC DIC format. Now, what is EBC DIC? EBC DIC stands for ASCII, is the American and signal code information system, ASCII code. Here and besides ASCII, we have EBC DIC because IBM computers are using this format of data. What is EBC DIC? This is an extended binary coded decimal information code. So it is different from an ASCII. ASCII is a 7-bit code, whereas the EBC DIC is an 8-bit code. So when we are going to, if the information is in 7-bit or 8-bit, and if the receiver is accept 8-bit code data, so it if we send, if the sender transmits 7-bit in data in or data or information in ASCII code, so at the receiving end side it will not be understandable by the receiver. So there will be a message format of a message, so that both sender and receiver could able to understand the information. So this falls under message formatting. And then security, we have to send the data in a secured way to the between the sender and a receiver. So security is another task of communication, so that the third party will not able to see the information that has been sent through the transmission medium. And last one will be the network management. This is overall management of the network. So these are the communication tasks that has to be fulfilled to send the information between the sender and the receiver. So I am ending up here. And this this Thursday I'm not going to take your class, because I have to take a class test, and I have a class with first year, because their event sem is going on. So I will take your class again on next Tuesday. So thank you very much to all of you who have attended my class. Thank you very much. I am
Thank you.
leaving.
Thank you, ma'am.
Okay.
Thank you, ma'am.